Hello, protocols, packets, and programs. As I noted last time, our episode numbers have moved into HTTP status code territory. So, with HTTP 301, where should AppSec be moved permanently? Does it develop lists for developers to develop secure code? Does it maintain the proliferation of prefixes for types of phishing? Does it become 2 more decades of dealing with CVEs? I hope we find an answer soon, because there's an ominous 404 not found in our future. Which means this week we redirect your attention to an end-of-quarter news roundup. Check the location and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Imperva, a Thales company, is the cybersecurity leader that helps organizations protect critical applications, APIs, and data anywhere, at scale, and with the highest ROI. With an integrated approach combining edge, application security, and data security, Imperva protects companies through all stages of their digital journey. Imperva Threat Research and their global intelligence community enable Imperva to stay ahead of the threat landscape and seamlessly integrate the latest security, privacy, and compliance expertise into their solutions. Start a free trial today at securityweekly.com/Imperva. 61%. That's how many U.S. businesses experienced a software supply chain attack in 2023, according to Gartner. This attack surface is constantly expanding. To secure your software supply chain, you first need to control it. JFrog offers an end-to-end platform that manages and controls the binaries and DevOps processes across the entire software development lifecycle. With JFrog, you can deliver trusted software with speed. Visit securityweekly.com/JFrog to learn more and take control of your software supply chain today. In 2024, the future of identity, security, and digital transformation converges at Octane, hosted by Okta. On October 15th through 17th, join the brightest minds in tech and business in Las Vegas or online as they explore groundbreaking innovations and unveil the latest Okta solutions to keep your organization secure, connected, and ahead of the curve. Whether you're a developer, an IT or security leader, or a visionary, Octane is your gateway to transforming tomorrow, today. Security Weekly listeners only need to pay $100 for your full conference pass for Octane by using the discount code OKTNSC24 at securityweekly.com/Octane2024 and can stream the event live on okta.com/Octane. That's OKTANE. This is episode 301, recorded October 1st, 2024. I'm your host, Mike Shima, and I'm here with Farshad Abbasi. Hello, Farshad.
How are you doing?
Doing very well. We haven't seen you in a while, so it's very nice for you to come join us for an extended news segment.
It's great to be back, and good to see you too, Mike.
Yeah, and so to jump right in, we've got a lot of, I think, fun things. We'll find out near the end and check back in. That I'm going to have a theme of threat modeling emerge from this, but we're pretty vulnerability heavy today. So let's start off with some vulns in Kias. So car hacking, this is some work from Sam Curry, whose work we've covered over the summer, I think even last year as well. Once again, they're dipping their toes, I'm not sure what the best car metaphor is, dipping their gas pedals back into hacking. But this one stood out because it's almost like a purely, just call them web-enabled cars. It's purely web hacking, web APIs that, just by the way, can do things like remote start, remote unlock, things that you probably really don't want somebody who knows where, unrelated to your location, doing to your car. And I think, for me, Farshad, what stands out here again is like, everything, it's great work. It's a great write-up, but everything is so much just web-based, that I think maybe one of the things here is almost take it from the user perspective of how surprised would you be, for example, if you didn't do anything with your quote-unquote connected car, and somebody just had a license plate that of your car, and they were able to remotely control it. That seems like something that would very much surprise a user.
Yeah. Yeah, totally. I mean, and it sounded like when I read the write-up, it sounded like it was fairly straightforward for them to find it, right? Because they basically found the API that converted the license plate to the VIN, and that VIN could be used to interact with the API that takes the request to open your car. And so many cars these days have that capability. Like my car has an app. I can go and lock and unlock my car door. And this is definitely, even if I didn't have the internet connectivity, that option would still be there. And that for the Kia one, apparently it affects a lot of models produced after 2013, which is pretty wide range. And this attack can be executed in about 30 seconds. I watched the video that they had on the write-up, and yeah, it just blows your mind that everything, like we think of these sort of embedded devices, but these embedded, a lot of them, majority of them these days have some sort of a web API interaction with the internet. So yeah.
I know I'm laughing because it's funny to think of your car as an embedded device, usually, but that's exactly what it is. And I think the other angle here too is, it's pretty much purely just web-based attacks. So yay web, but
Yeah.
it's going through the dealer, website as well. So it's not like this is just the customer, even customer support or the customer oriented. There's a lot of ways, if you will, into these APIs. And it's that type of attack surface, which listeners may pick up. The attack surfaces might be another one of our key themes for the day of just, how is your car exposed, or how is access to your car exposed?
Yeah, and what are the different possibilities, right? So in this case, hey, you're able to open your car remotely. There's got to be a way that this happens. Oh yeah, there's like, is it receiving requests? Is it sending requests? What are the potential threat scenarios for someone to compromise your car? And has the manufacturer dealt with it? That sort of thing.
Yeah, and so related to cars, the other type of embedded web we might have on our devices is printers, or I should say maybe printing to be a little bit more accurate. Possibly very unrelated in terms of what the devices are, but there was a big RCE, a lot of, I will use the capital D word, drama kind of leading up to this release, or this disclosure. But ultimately, there are some multiple flaws within CUPS, the common Unix printing system, that is present that can be present, but not necessarily present by default on, for those of you who like to call it GNU/Linux, or just Linux systems, as well as, Mac OS, BSDs. These things are potentially there, but ultimately it boils down to, I won't completely. I'll give it. I won't give it maybe one shrug rather than two shrugs or half a shrug in terms of what the impact is. But yeah, it seemed like, this is not like the Heartbleed, the shell shock that was like all Linux systems are going to be exposed, and this is really emergency of a CVS 9.9.
Yeah. And it's interesting. I mean, it impacts a lot, as you said, a lot of different OSs, even like, Google's Chromium, Chrome OS, Solaris, all that kind of stuff. But, it's if you have that CUPS browse service enabled, right? So I think from what I understand, the flaw allows remote attackers or unauthenticated attackers to execute arbitrary code on those systems. And it's how they do it is exploiting the CUPS browse service and the related libraries, so that these can be manipulated to execute commands with root privileges when a print job is initiated. So if that's the threat scenario, going back to threat modeling, if that's your case, you got that service, and is it possible for someone to actually make that connection if this device is on the internal network, et cetera, that all contributes to what sort of action. But bottom line is update, always patch, update, right?
Yeah.
Where you can.
Bottom line update, but and also too, like, why are you like? Why is this enabled by default on anything that's your server?
Totally,
it's just unneeded, and I think that's the case for a lot of these systems as well. Is that really what the exposure to all the scanning that's done through indirect scanning through Shodan or direct scanning? Who knows how many of these are actually honeypots that people have set up because they just want to see, I'm going to run a printer service and see who attacks me, versus people who have this internet exposed for some reason. But as you said, I think the key parts here, it's not universally present, universally enabled on a significant amount of systems that we care about, in the sense of servers that are typically exposed or intended to be exposed to the internet. And the other aspect of, requires user interaction. to pull off the full RCE. So good research, good findings, but it doesn't have that feeling of heartbleed, for example.
Totally, totally. And if everybody follows that principle of reducing the attack surface by disabling unnecessary services, that solves a lot of problems, right? And then, of course, you can also block traffic to port 631 as another layer in your defense, layer in defense design, essentially.
Yeah, and so let's continue our journey onto attack surface and talk about a slightly different way of it in the sense of memory safety. So in the sense of changing the attack surface of our C and C++ code, or AKA our typically memory unsafe code, into Rust. Everybody loves Rust. At least we or I talk about Rust quite a bit here. This article is from the Google Online Security blog talking about eliminating memory safety vulnerabilities at the source. And they're making really just their point is, rather than if you have a bunch of memory unsafe code, bunch of code that's written in C, C++, take the option of writing new code in memory safe languages rather than considering an option of rewriting the entire thing.
Right.
And I think that makes sense. I'll speak for John in this case. I think it's fair to say that he would agree with this type of sentiment, because we always have a little bit of back and forth where I just love the idea of refactoring, recoding, and writing code for the sake of code, as opposed to what John correctly points out. You got to deliver features. You have to have a service that's, if you're a business, be making money, have that revenue generation. You can't just write code for the sake of it.
Yeah, absolutely.
And but I think one of the catches here that it sort of glosses over is that you still need the framework and infrastructure to be able to support Rust, for example.
Yeah.
In the Linux kernel, we saw Rust be introduced for device drivers, I think last year, if memory serves correctly, but that was at least a year before that it took just to get all of the tooling, the compiler infrastructure, et cetera, to be able to support Rust so they could build like a single Hello World driver.
Yeah.
So there is definitely some hidden cost here just to be able to say we're going to mix our C or C++ with Rust.
Totally, totally. I mean, yeah, there's more wider support for C++ across various platforms, and newer languages like Rust, they may have limited support on certain hardware. But then there's also things like, the learning curve. So people that are familiar with C++ may find Rust's unique, way of doing things challenging to learn initially. And then there's also, like, if you have a large legacy code base, transitioning those projects in C++ to Rust can be a massive project or undertaking. So rewriting critical components incrementally rather than, doing a whole overhaul and things like that should also be considered. But yeah.
Yeah, and that's where critical components, I'm glad you mentioned that, because to my mind, a couple things come up in the sense that you've got like the Proximo project that's writing a Rust TLS that's ideally a drop-in for OpenSSL. So if you're just using the OpenSSL APIs, you could probably, and I say a bunch of caveats here, it's never as easy to do as it is to say, but the idea is to replace OpenSSL and its legacy, I think it's fair to say, C code base with the Rust implementation that's API compatible, ideally more performant as well. So that's one area. But if we were to say, what are those critical components? Device drivers in Linux, I mentioned already, because those are common sources of vulnerabilities. They're also potentially quite varying in code quality, but they're running in kernel space, and that could be a very bad thing.
Yep.
I'll throw out another critical component is any parsing you're doing, especially if it's parsing user-generated content. And that could be whether it's XML, text probably is not as bad, but like any codecs, video or audio codecs, those types of things. So I don't know if I've rattled off that list, are there other critical components that you would pick as, if, for example, to say, let's focus on this area with our Rust re-implementation rather than just grab a function for the sake of grabbing a functions in alphabetical order.
Right. Yeah, that makes sense. And then, Mike, another thing to think about is integration as well, right? Because if you have an existing system and you want to integrate Rust into it, you might have to change your build system, your debugging tools, your development workflows, and all of those could be resource intensive. I read somewhere that in some industries, switching to a new language may be hindered, might be regulatory requirements that mandate use of proven technologies as well. So in some cases, that might be something as well to think about.
Oh, interesting. Yeah, there's always surprising regulations, or I should say, surprising interpretation of regulations
Yeah.
out there. Maybe
Yep.
maybe that will be a segment for another day.
Yep.
But
Yep.
I don't want to lose anybody with regulations. Let's keep the
No.
roll onto our attack surface. So, if that Google article was talking about memory safety and basically saying, find those critical components, and write new code, rewrite those components in that memory safe language. Take a risk based approach. It's a way of reducing attack surface. Here's another angle on attack surface, which is a progress update from Microsoft on their Secure Future initiative, where rather than talking about new code and the new code that they're writing, they went through and talked about, with some numbers to back it up, they completed, quote, a full iteration of app lifecycle management for their production and productivity tenants, which turned into, and these numbers were maybe not surprising at scale, but were still impressive. They eliminated over 700,000 unused apps and eliminated almost 6 million inactive tenants.
Wow.
That sounds like a great attack surface reduction right there.
It says they dedicated the equivalent of 3,400 full-time engineer sets to this initiative. Wow.
Yeah, and that is a significant investment, and one would hope that dedicating that much engineering time obviously has a direct time and money cost associated with it. What would have been kind of cool is if they were able to say, we eliminated these unused apps, we eliminated these inactive tenants, and by the way, we saved this much cost.
I was just going to say cost savings. Yes.
Yeah, and that's a way to say, I don't know if it would fully offset it, but I would imagine over time that there's got to also be just the cost of CPU, cost of storage, as well as just the developer cost of complexity, maintaining that amount of scale. I would really just hope that there are really good benefits that developers are seeing from that as well.
Yeah, and I think there's also a lesson for smaller companies as well, right? I think everyone should look at this and try to make sure they manage their assets, things that they're not using, they clean up and all of that. I think it's for all of us to think about.
Yeah, and thank you for that point, because I don't think that everybody quite has 700,000 plus apps that they're not even using right now. Maybe it's ideally down to 7 or maybe 700. But yeah, that app lifecycle just terminated. When do you decommission something? And every place I've worked at has always been that situation of, oh, this was decommissioned, 2 years ago, but we still got a bug bounty report for it. Or the Vulns scanner found something. There's decommission because developers kind of just stopped caring about it, stopped feeding it. And there's decommission like it was actually shut down, the data was deleted, etc. Two very distinct and very different outcomes that we would much prefer the latter.
Absolutely.
There is another angle too on this where I love that lifecycle management aspect, but speaking of what other small companies can take advantage of too, they also emphasizes that they're using, in this case, HSMs for generating, storing, rotating signing keys, token signing keys. And also another quote from the PDF that I linked to as well, isolated their credentials within boundaries. So security boundaries we'll come back to when we talk about threat modeling some more. But they are dealing with over 100,000 certificate registrations.
Oh, wow.
So that's just a huge opportunity to leak a certificate, have which we've seen in the past, or have certificates be improperly provisioned, then reused, or have improper scope. They're not constrained or isolated as they're describing now. So this was very specific to some Outlook, I believe, if I remember correctly, problems they had over the summer as well. So I think the story just comes down to automate secrets management and keep those secrets as narrowly scoped as possible. And that's anybody can follow, right?
Yeah, and if your application is in the cloud, there's no excuse, right? Because Azure, AWS, GCP, they all have KMS or similar functions. A lot of them can have the HSM back option. You got to be using those. If you're not, you do it right away. If you're on-prem, that's a different story, right? You can still implement HashiCorp Vault. You can still implement some sort of central key management, service and do it that way. So there's a lot of great options these days. Whereas, say 10, 15 years ago, it wasn't the case.
No, and in these days, I have another article that from the Cloud Native Computing Foundation that's talking about the state of cloud native development in 2024. And speaking of secrets management, there was a list of must-do items that mature organizations saying this is what we should do when you're doing cloud native development, and they in the article reports what percentage of mature versus less mature companies are doing this. But what struck me, 65% was the number of mature orgs that are handling secrets management, or that's a must-do aspect of cloud native development, versus 45% for less mature orgs. But that number seems so low. That just seemed to me like that's just a must-do, and it's not difficult either. So that was one of those metrics that just made me go, I wonder what's going on here.
Interesting.
Yeah, and that's where I don't know if this list. So the list does cover things like code review, managed configurations, AppSec, overseeing CI, CD, the secrets management on there. It talks about dependency updating, which is the necessary evil these days. But I don't know of this list. Did this list look like a must-do that was familiar to you, or is there something missing from this list, do you think?
Was there something that was missing? I mean, I think a lot of it was pretty familiar to me. Nothing popped into mind. I mean, I just was, it was an interesting list of things that they published, but yeah, nothing jumped out.
Yeah, and I think in some of it too, I guess the other angle is a lot of this is just the practices around code, around building code. It's not exactly the practices of the code itself. It does talk about doing code review. So I shouldn't be too dismissive of that. And that's like 80% of these mature orgs are reporting doing code review. But I would love to know the type of code review that they're doing, because I want to talk about like business logic or those types of vulns that perhaps can come up. So an example for another day, perhaps. But we've got another cloud-related article from Tenable called Cloud Imposer. And this is what boils down to a dependency confusion attack that is able to be executing code on millions of Google servers with a single malicious package. And they go through a bunch of preamble that it took a while to get through to the meat of it. So you do have to scroll down a bit. But it's a good explanation of dependency confusion attacks. So I like it from that perspective. Encourage you to read it from that perspective as well. And then it gets into what stood out to me and what I went on a tangent on. They're talking about PyPy.
Yep.
Python, and talking about a PEP 708. And the PEPs are basically Python's way of handling RFCs, or how do we extend the language.
Right.
And this was from February 2023. A discussion started on a way to mitigate dependency confusion attacks just in general. So this is a way, rather than do one-off fixes for a bunch of different repos, or tell everybody to reconfigure something to a different default. Here's a default behavior that is suggested for avoiding or mitigating lots of the most common types of dependency confusion. But the discussion started in 2023. It wasn't until August 2024 that there was actually a reference implementation to help move this forward, to have an impact. And that just stood out to me as, on the one hand, good for them for having the diligence and the patience to try to keep pushing that forward. But wow, it's just an example of a journey here's a good idea, and look how long it takes to turn a good idea into execution. Because honestly, it's that execution that has the impact, right?
And isn't that the challenge, Mike, with most of these types of standards and these things that get proposed? Like, look at changes to RFCs. There's like problems in them, but it takes so long to address them. And then by the time the industry moves on, a lot of times historically, look back at HTML, right? It took so long for the standard to move along, and then people started to deviate from the standard. Usually, I mean, there's sort of that, hey, we need standards and we need process and these, Python enhancement proposals and, all this stuff. But at the same time, the world moves quite a bit faster. I'm not really sure what the answer is, but yeah, knowing this whole cloud imposer vulnerability was was pretty classic, right? I didn't know much about it. I went and read up, and I guess the GCP had this composer service, and there was this extra index URL parameter that's in pip. So that allowed fetching things from public and private repositories. Classic dependency confusion. If you have it in the public one, it'll go and get that first, and game over. So yeah.
Right. And yes, exactly. And it's that idea that the confusion comes from, here's the package that internally we're using. It's our own special name and we're on version 0.1. But if an attacker has some knowledge of that package, they could just say, oh, look, by the way, this package server has version 0.3. And so pip is just like, cool, you have 0.3, that's bigger than 0.1, I will download and run. And it just so happens to have the, malicious code, RCE, what have you in there. One of the other things I wanted to highlight about this discussion, especially around the PEP, was that it was there was a quote in the discussion around it that goes, they point out this was a very good balance of safety versus convenience, and the participant was saying this fondly because many security proposals do badly on both, assuming safety is so important that convenience, meaning convenience for developers, is largely irrelevant. And that's just a really nice reminder that, especially I think the modern AppSec, modern approach and engagement with developers is not anything like, don't do that, stop doing that, or here's a checklist to adhere to. It's like, what are you trying to accomplish? Let's help you accomplish that in a secure manner. And that's where the threat modeling comes in. So why don't we jump to another article very specifically on threat modeling from Trail of Bits. And Trail of Bits, we love covering their blog articles. We covered one just, I think, 2 or 3 weeks ago. This one is a few notes on AWS Nitro enclaves and talking about the attack surface. So even if you are not familiar with Nitro enclaves or using them, this is still one of those articles to read through, to learn from, in the sense of learn from how they consider what types of attack scenarios are out there, learn how to have the language about say up front, these are the assumptions we're going to have. These are the different things that we're going to consider our trust zone, our trust boundaries. And if, activity is happening within a particular zone, that's okay. But if it crosses a boundary, that's what we want to avoid. And so I think some of the things, what was I going to say? So up front, just as some examples, they're talking about, they're going to assume, just say that the parent instance's kernel can be controlled by the attacker. So you don't have to demonstrate this. They're just saying, what if the parent instance controlled by the attacker, the whole enclave itself is a single trust zone. So it's not the idea that, well, if you can execute code in this one particular process, but not other processes, that's okay. It's that the boundary is that, are you within our enclave or not? And then they list out a couple different ways that might, that attacks might come from. And I wanted to highlight these attacks because they're not purely aligned with just something like Stride. They're something generic. They're talking about randomness, side channels, memory management, where the time comes from, and attestation. And these are things that are kind of domain specific or common to the enclave or common to this setup, that if you're just using something like Stride, might not get you there. And so that was a little bit of the soapbox I just wanted to highlight, in the sense of, when we say threat modeling, don't just go to the acronyms, go to those 4 questions of what's being built, what could go wrong. And it's just that what could go wrong, it can be very open-ended. Something like Stride can help nudge you towards some domains of problems. But developers are pretty creative, and they kind of already worry about bugs, implementation errors that aren't necessarily security. So they just need to start off with that discussion of what features could go wrong, and then have a little bit of that help to nudge them into, what are some security considerations of this?
Yeah, exactly, Mike. And that's what I usually call, doing threat modeling on the requirements. In the modern day, they call it user stories or whatever you want to call that. But essentially, as you're building something, as you said, as that you take the requirement or there's a user story and you start develop something, think of what the abuse case could be. How can that be used in the what is the evil story there, right? If you do that, then you've covered everything. But if you're only looking at that high level, the stride view, the architectural view, then you're going to miss a lot of the detail or the particular abuse cases that could come about because of specific functions in your system.
And this is where we could apply this, back to that first article we started off with, the hacking Kia from Sam Curry and folks, because it also calls out a couple of these situations, examples of threat modeling or what went wrong or what could go wrong. So, you and I, Farshad, we could say, well, if we have the key fob and you have to have physical access to the key fob to intercept, the unlock code that's being sent, that's one case. But if we forget that this is web enabled and there's a web API behind this that can still do the remote start, remote unlock, we failed a bit on our threat model.
Yeah.
We have to consider what are the different ways of accessing this, right?
Exactly. And that's where hey, here's all the functions or the requirements. Hey, the user should be able to do this and that, and then you go through threat model each of those. But it can be pretty time consuming. So, I know when I started in the threat modeling world, it was in the waterfall days, and then you would get, where the requirement stage was done, and then you got a ton of requirements, and you had to sit and threat model them. But nowadays, when people are building things iteratively agile, it's a lot easier. So every sprint, take the requirements or the user stories for that sprint, review them, threat model them. If you have to do this after the fact, yes, there's going to be a lot of work because you'll have to take a thing that's already built and look at all of its functions and threat model them. But ideally, you do this iteratively as you're building it, which makes it a lot easier.
It does. And that's where one of the reasons that hopefully I'm not repeating myself here, but one of the reasons we like to bring up lots of vulnerabilities, but generalize them so that it's not like, here is a vulnerability in cups. Maybe you're not running that. Maybe you're not dealing with UDP traffic, but there might be some principles there that you could say, oh, does our own application have this similar behavior in the sense of what does it take to register someone, to register a printer, for example, or in this case, to register, like in the case of the car hacking, to register a user who has access to it. And in this situation, it was showing if you had the license plate, you could register, and perhaps maybe you need the VIN, you could just register an email address. And now your email address through the dealer website, you can actually have access to the car. And what they also point out is now, so there's registering to self-registering, but there's no notice to the owner. So for example, it might not say, hey, Farshad, did you know that Mike just registered himself as a co-owner of your car, or this is your account has been modified? These types of these are reactive controls, if you will, but it's engaging the user to say, did you make this change? Or here's a consequential security change or a security related change to your account. Does this matter? Do you recognize this? So that doesn't necessarily come up out of something like Stride, but I think it's a good type of feature when you're going through threat modeling to consider, to try and talk about.
Yeah, absolutely. And ASVS provides a good list of those types of controls to consider for developers.
Ooh, ASVS. That's a good setup, because mentioning ASVS, there is another article here that is a little bit old, but NIST Special Publication 800-63B in particular got updated this summer in August, I believe. But the slight update was going from, in speaking of regulations or standards, Farshad, it went from a should not to a shall not regarding password complexity. And to translate that for listeners, what that really means, it went from a suggestion to a requirement, meaning there's no longer a requirement to have password complexity, which honestly I think is wonderful. And it means we can go and get rid of all the password strength calculators out there every time you're trying to sign up for something.
I totally agree with you, Mike. I think it's a great thing. I mean, enforcing those special characters and that password complexity just causes people to substitute things that are pretty easy for attackers to figure out as well, and all kinds of other problems that we can talk about over a beer. But what's going to be funny though? Actually talking to people and saying that that's not the case anymore. Like the average person is like, whoa, what are you talking about? Password complexity? You don't need it. All these years I've been told you need it, right? Like I can just picture having those conversations that are going to be like, this is what security people all always said. Now you're saying you not do this. And
And that's an important nuance to call out, especially because, it's October 1st, right? So it's officially Cybersecurity Awareness Month. So
Yes.
hopefully you were aware of that. But you're very right to point out that if a user is saying, well, you've been telling me I'm supposed to put in all these special characters, that it's going to be brute force targeted. Now you're changing your story. Why? What's going on? This is where I think it's very strongly the responsibility on InfoSec community, AppSec community to explain. And one of the ways I would approach that is that password complexity from the very beginning was really about making a brute force attack more difficult. But that was very more specifically an offline brute force attack that assumed someone had gotten the password hash. So if I give you a password hash, or the old school, NTLM, that landman hash password that's limited to, a 14 character password is actually 2 7-character passwords. If you're doing an offline brute force, sure, you're making millions and millions, billions of guesses per second. That's what complexity was ostensibly intended to prevent. But I would highlight that if someone has already compromised that password hash, or they're able to obtain it, there's other problems already. So that's not really what password complexity in the modern age is trying to prevent, or I should better phrase that as, that's not the major threat that password attacks have. The major threat is more of password reuse because they've been exposed somewhere else. The major compromise is malware on a system that just grabs your password, or phishing where you type in a very complex password into the phishing website and there's no additional MFA or secondary authentication that prevents that from being misused. And so that's how we'd try and say, dear user, the threat landscape, the threat models have changed. While password complexity originally was well-intentioned, it gets a very specific scenario where the password hashes, that hash database, had been compromised. That's not how people are attacked these days. That's not where passwords fail users these days. So it's a long-winded way of saying, trying to come around to that. So I thank you for your patience. But let's see. Let me poke Farshad and see if he's still awake or if he's been changing his password this whole time.
One thing I just want to add to this, Mike, before we move to the next one, is one of my pet peeves is that some sites don't let you select long passwords, right? Like I have a password manager. I'm like, hey, make me 32 character passwords. A lot of them are like, oh, you can only have 20 characters, 18. I'm like, well, what is this? I mean, if I were to pick a passphrase, it'd have to be a lot longer than that. So that's one of the problems that I see. And I see that kind of a thing in a lot of those like insurance companies, sort of like my life insurance, whatever, you go in there to log in, these sort of massive organizations have old school password, like it's 18 maximum. You have to have special characters, all this stuff. And I'm just like, wow. But we'll see how quickly they will adopt to this kind of thing.
We will. And that's a good point. Let's chat about password length for a second, because to some degree, depending on what the hashing mechanism is on the back end, some lengths may not, aren't helping you. And so we'll have to look up what like the scrypt maximum is.
Yes.
But and also too, if we're talking about phishing, let's say that we created that 32 character password, 40 character password. If for some reason, of course, neither of us would fall for that, being podcast hosts, which I say with utmost facetiousness. So please trust me on that. But if someone were to fall for that, they type in that 40 character password onto the phishing, that didn't help you. And again, you're starting to get into, wow, do I really need to cut and paste? Well, hopefully I can cut and paste, because if I have to type in 40 characters, that's just madness.
So is MFA the solution then, Mike?
Passkeys. That's going to be what I'm going to be the huge fan of, because I like the passkeys because they have the properties of being in the secure enclave for your device, so more difficult to extract. They also have the properties where they're binding cryptographically to the site you're authenticating to. So this way too, it's a way to make them very phishing resistant. It pretty much destroys that the replay attacks that can be done, or the reuse across different sites. So I can have a passkey for site A, it doesn't matter if it's exposed, whatever, because my passkey for site B, it can't be used for that, even though it's an identifier for me. So it's a way of preventing, password reuse in good cryptographic manners. So far, Shad, speaking of passwords, we've got one final article here. Meta fined $100 million for storing hundreds of millions of passwords in plain text. This actually dates back to an article from Krebs on Security from 2019 when he covered this, saying that Meta actually self-reported that they had discovered that some of their services were incorrectly, because you can't correctly log passwords, or you shouldn't correctly. I don't know how you could correctly log passwords, logging passwords. So this wasn't like their password store on the back end wasn't hashing. It was, we need to log events. This is something we talk about on the show a lot. Observability. You want that to be able to inspect traffic, know what's going on with your API. But you don't want to extend that logging into things like sensitive data, like passwords, or for that matter, other personal information, things like social security numbers or other types of data that might put you on the reporting a breach path and saying we take security seriously. So this is $100 million of serious security that came out of mistakes. But I do want to take the angle of this is good from transparency for self-reporting. Yes. We can maybe be a little bit cynical, and they had to self-report this because it was going to leak or be discovered in one way or the other. But still, it's a positive thing. Because, and I say it's a positive thing to be clear, not that they were doing this, but that a company like Meta can make this mistake. And I think we'd seen Twitter has done this in the past. GitHub, I believe. There was, in the long time ago, I believe both Yahoo and LinkedIn also fell into this trap of plain text passwords had been logged or mishandled at one point, and there was a cleanup necessary. So it can happen to small companies as well as big companies.
Happens everywhere. Yeah, and I mean, you touched on a couple of things, Mike. Like it can, it can be exposed in logs, and also in the place where there's a source of truth for those passwords. Right? Like I've seen companies that just use a Postgres database, username and passwords just put in there without encryption, right? And then of course there are the cases where their logging systems actually end up putting those things in logs. My usually stance on this has been, don't log passwords. Like, that's just anything that is highly sensitive, like passwords, keys, and things like that should just not be in logs. That's just because some people are like, well, you can encrypt them and put them in logs. They're like, why would you want to do that? That's just avoid it. And those were when I worked in the financial sector, that was the guidance, is like highly sensitive things like passwords, just don't get logged. In terms of storing them somewhere, well, ideally use a proper identity provider. Use an IDP. Like if you're in the cloud, there's all these IDP options. If you're not, you can roll your own. There's like lots of IDP on-prem services that you can roll, and those things are designed to protect passwords properly. But if you're really ultimately doing your own thing and putting these things in a database somewhere or in a file store, like I did in 1997 when I made my first web application, make sure you're applied like Recrypt or Argon or something, right? So.
And one of the challenges here too is, it's again easy to say, just don't log the passwords. Sometimes you may not realize the passwords are part of that traffic though, or part of that log entry. So it's one thing to say we are logging, our format string has a password field in it. That's pretty easy to grep for and say, whoa, why did we do this? It's another thing to not realize, oh, we captured some post traffic. It just so happens that post traffic had password. Those are our authentication points. That's a careful area to be careful about. And I will extend this to being careful. Like, definitely don't do the passwords. I'll agree with despite my joking, that just don't do that. But session cookies. So we've seen in the past is session cookies are a great way to get that post authentication impersonation. Yep. And it was Cloudflare a couple months ago where part of their customer support mechanism process said, capture HAR file, your HAR file, your HTTP archive, so that captures, dear customer, capture this as you log in, provide it to customer support, will help you debug what's necessary. That sounds like a good user experience. It's a good way to figure out what is the user doing. But if those HAR files have your session cookie and that session cookie hasn't been invalidated and the attacker can compromise that session cookie, they can log in as you. And
No,
that's what
just
they
that,
discovered. And they had that HAR file sanitizer now to help avoid these types of problems. So this goes beyond just passwords.
Mike, this whole har file thing too, I just want to add something. Every time you contact Microsoft for support, they insist on sending that. I had a recent problem that had nothing to do, it wasn't not a front end problem. It was a totally back end problem on their systems. They weren't updating my name on the account, nothing to do with the front end. Back and forth. And they're like, the only way we can support you is giving us a HAR file. And they came and they made me record it and do that. I'm like, I know this is going to expose a lot of stuff, like you said, right? And then later, of course, it was a back end problem. It had nothing to do with the front end or HAR file, but they insist on giving it every time, which isn't something I'm a big fan of. But
well, next time they ask for a HAR file, just send in a recording of you clicking subscribe on the ASW
we're probably not going
podcast.
to look at it, right? Because it wasn't even related to my problems.
Exactly. And Farshad, I think that we'll wrap things up on that fun note. So thank you once again for joining. It's been a while since we've had you on, and this was a great conversation with you.
Awesome. Thanks for having me.
Well, I say thanks you once again to Farshad. Thank you everyone for joining us. Please do remember to subscribe. No HAR files necessary. Please also share on the socials. Check out the show notes. And speaking of having fun, check out Neotropolis by Starfarer and Knight Rider 87. We'll see you next time on Application Security Weekly.